Hello and welcome to my EGB345 tutorial portfolio 10. So we're just going to get straight into it. This is task 1 and we're going to go through parts A and B. So task 1A, we're asked to find the K value for an overshoot of 5%. Let's plug that into the formula for eta and we get approximately 0.707, which works out to be a 45-degree angle on the complex plane. From there we can determine the poles mathematically using the quadratic formula, and then we can find the sigma naught and theta k, which will give us the asymptote points. So by marking our poles, we can then draw the 45-degree angle on the complex plane to find the ideal poles. And so they turn out to be at negative 1.5 plus or minus j 1.5. And to find the k value, we just sum up the lengths between the poles and the ideal poles. For example, d1 is here, d2 is here. So it's just simply 1 plus 1 divided by 1, which gives you 2. And the natural frequency is just the real pole equals eta times the natural frequency, and therefore you can say the natural frequency turns out to be 2.122. We'll now move on to task 2. So task 2 asks us to find the gain for a settling time of less than 4 seconds. So I've just reiterated the formula there with the gain added to the formula. So we're going to let TS equal 3.99 seconds. This will account for any rounding errors in the next few formulae, so that the settling time will always be under 4 seconds, roughly. So we can find the eta value for the settling time of 3.99 seconds, which comes out to be roughly 0.707, which is 45 degrees, which is an ideal angle to work with. Similarly to the previous question, we can now calculate the poles, zeros, sigma, and theta values so that we can draw the root locus. From those points calculated before, we can see that the poles are drawn in here, the 0 right in the middle here, and we can see it makes this nice circle curve. So we can draw these lines out at the 45-degree angle of which we calculated before, and to reach an ideal point of negative 14.5 plus j 14.5 and negative. So now finding k is just as simple as plugging in our values into the formula. So we rearrange this formula to find an expression for k. And then we go through and substitute in the positive pole value into this equation here, and this gives us this, and then take the absolute value of negative 28 gives you positive 28. Finally, you just have to calculate the steady state error for the step input. So like above, you just sort of substitute in 0 for s, and then step through this equation, and it comes out to be 0.00118. And then task C asks for the zeta value, which we've already calculated as 0.707.